So I believe we have a quiz coming up on 10.3 and 10.4. Don't flip out though, right? It's going to be okay. Um, let's go over some review problems. Mostly I'll fly through the answers and maybe quickly show you how to do them. Nobody asked a single question. I don't think anybody's been to help session all week, so I'm assuming that means you guys think you're all really doing well. I hope it doesn't mean that you guys have decided to stop doing things. We already went through these and these and these and these and these and these last week for the quiz on 10.1 and 10.2. But here are the first three answers for the rest of your worksheet. What we've got with 25 is a direct application of Theorem 10.3. We know 360 degrees will go around the entire circle, and so I can subtract 130 from 360 and determine that the rest of the circle is 230. But Theorem 10.3 tells us that congruent chords intersect congruent arcs, including arc AB, which is the answer. 10.5 tells us that if we have a diameter that is perpendicular to a chord, it will bisect the chord. Bisect the chord. Now, on that note, a diameter also will create two semicircles, right? So semicircle 180 degrees, subtract 125, and then because the diameter is bisecting the chord, it's also bisecting the arc. So AB is 55. Now on number 27, we have two chords that are perpendicular, and one of them is bisecting the other. That means that the chord which is bisecting the other has to be a diameter by theorem 10.4. Because we now know that BD is a diameter, arc BAD up here, arc BAD instantly becomes a semicircle. So 180 minus 135 is 45. 28. What do we know about these pictures? What can we conclude based on what we see? Well, this is basically the same exact theorem we just talked about on 27. I have two chords which are perpendicular, and one of them is bisecting the other. The bisecting chord has to be a diameter by theorem 10.4. Problem 29, I have two congruent chords, and so by theorem 10.3, the arcs that intersect AB and ED are congruent arcs. And then number 30, we haven't seen this one yet on this worksheet. Congruent chords are equidistant from the center of the circle, and that's an if and only if. So if two chords are congruent, they have to be equidistant from the center, and if two chords are equidistant, they have to be congruent. In this case, we see I shaded these distances green. We see the perpendicular congruent distances, and that means that those chords have to be congruent to each other. Segments A, B, and D, E are congruent by theorem 10.6. All right, 10.4, we got into a lot of angle stuff, inscribed angles, mostly. They all kind of dealt with inscribed angles. Number 31, what we have is we have a diameter. You've got to always keep your eye out for those diameters because they will always give you those semicircles. So if you ever get stuck, just stop for a second and see if maybe you have a diameter, okay? I didn't mean for that 50 to uncover, but you probably could have gotten that if you did this 40 multiplied by 2. The inscribed angle is half the arc, so this would have been 80. And then we just said this is a semicircle, and so 100 and I'm not going to be able to write an 80 with this. 180 minus 80 would be 100. And if this is 100, half of that is 50. So I guess you could have gotten that 50. But I think the easier way of doing it is to use theorem 10.8, which says that if you have a diameter, any angle inscribed within that diameter has to be 90, right? Because half of 180 over here is 90. And then you're right, triangle, you subtract 90 and the 40, boom, you're done. But there's a couple ways of doing that. Now, number 32, I guess X is inscribed in a 140-degree arc. And because of that, it has to be half of that arc, which is 140. And half of 140, of course, is 70. Now, why might have confused some people, because they're like, wait a second, they didn't give me this arc, so how do I know what that is? Well, the good news is you don't need to, because both of these two angles are inscribed within the same arc, which means that whatever this arc is, they both have to be half of the same number. And this is theorem, maybe actually that one's theorem 10.6, no, 10.8, I believe. Any two angles inscribed in the same arc are congruent. I get this one. I think was actually 10.9. I think I said it was 10.8. But anyway, the point is, once I know that those angles are congruent, one of them's 20. That means the other one has to be 20. Now number 33. It is. Well, I've got a couple different relationships going on. One of the relationships is I've got these inscribed angles here and here, and they have to be half of this arc, because inscribed angles are half the intercepted arc. So I could set that equation out. But I also have these two angles here and here that are inscribed in the same arc. So we really use the same two theorems we used on 32. Because of all the little writing on this one, I'll blow this one up just to make sure we understand it. See, there's that congruent arc. That means that 2x minus 5 and x plus 20 have to be half of the same green arc. And so that's what we're going to set up to solve for x. Okay. If this green arc right here is the intercepted arc by both of these angles, they have to be congruent to each other. So set them equal, and it's a pretty easy solve once you do. As far as the other one, we said that this inscribed angle has to be half of the intercepted arc. And so I think I think it's easier to multiply by 2 than divide by 1/2. So I'm going to multiply the y plus 27 by 2, do a little distribution. And sure enough, subtract 2, subtract 10, divide by 2, there's the answer. Okay. 34. Now we're getting into theorem 10.10, which was about inscribed quadrilaterals. Inscribed quadrilaterals always have opposite angles that are supplementary. Isn't it nice when you're taking quizzes that are open note? I bet that takes some pressure off, doesn't it? So these guys have to add up to 180, and these guys have to add up to 180. And I really don't see a huge reason to set these equations up, because it's just solving. So really on this type of problem, you would not need to show work, even though you're not really showing work on Google quizzes anyway. 35, same situation. This time we're using more variable expressions, so you probably do want to set it up. You do want to say that 83 plus 7y minus 1 is equal to 180. Or I guess you could subtract that that 83 from 180 and directly get that, 7y minus 1 has to be equal to 97. And it looks like that's what we did down here. Okay. Likewise, you could either add 9x plus 117 and set that equal to 180, or you could take 117 away from 180 due to the supplemental relationship and set 9x equal to 63, but that's where those guys come from. Number 36 is got enough going on that we probably want to take a closer look at it. So are you ready? There's a closer look. So notice that I have, when it comes down to it really, 4 different arcs because of the 4 different points of the quadrilateral, the inscribed quadrilateral. I've got this arc, I've got this big old honking arc. Some people may say, "Ooh, is that a semicircle?" But it tells us it's 168, and even if it didn't, they didn't put a center point in here, so you really can't make that assumption. Be careful about that. We've got this little guy right here, and then finally I've got this slightly larger one right here. So we know that those all have to add up to 360. So to me, and you don't have to do it this way, I think because you have enough arcs out here, you could start getting some inscribed angles. But I would go ahead and subtract the 3 known arcs. I think it makes your job easier once you know all of your arcs, okay? And then we just start looking at our angles. So for example, this inscribed angle right here, 13x, is inscribed in this arc, right? And 48 plus 56, it turns out, is 104. So that means this inscribed angle down here has to be half of 104. And what is half of 104? I'm glad you asked. It's 52. Divide by 13 and you know what x is. On the other side, we've got 8y. 8y is made up of these 2 chords, which inscribe this arc, right? This arc right here. And so the question is, what is 88 plus 48? How about 136? That's off the top of my head, but I was right, because half of 136 is 68. That's why we set 8y equals 68, and the division gives you 8.5. All right, so slightly more convoluted, but if you just look for the inscribed angles and the arcs and find what you can, eventually you'll find the right situation. Okay. We did 37 last week. We did 38 last week. So the last one you had to do was a proof, and it's been a while since you had to do a proof. But hopefully you had a good time with it. There will be more proofs in this chapter because there are a lot more traditional geometric theorems, okay? So what they give us is they give us a diameter AC, which is bisecting chord DB. Nope, they didn't say it was bisecting, sorry, they said it was perpendicular. So there's the perpendicular relationship. And they want us to prove that arc AD right here is congruent to arc AB right here. All right, so let's get to work. We always start with the given, don't we? Have to start with something. Now they want me to use the fact that all right angles are congruent, and I gotta call the book out on this one. I don't think we had right angles yet. I think they skipped a step. I think they told us AC and BD were perpendicular, and I think we could say that perpendicular lines create right angles. That's the definition of perpendicular lines. Or you could even use the theorem that says perpendicular lines create 4 right angles. But they skipped that, so they went right to the right angles. Anyway, I've got angle AED is going to be congruent to angle AEB, because as they say, all right angles are indeed congruent. The right angle congruence theorem, that goes all the way back to theorem like 2.3, I believe. All right, moving on. Why is segment DE congruent to segment BE? Well, I believe this is one of our more recent theorems. The reason that these 2 segments right here are congruent is because of theorem 10.5. A diameter that is perpendicular to a chord bisects the chord. Yep, I was right, theorem 10.5. So now I have a congruent angle and a congruent side. What I'm trying to work toward is a couple triangles. I've got a triangle on this half and a triangle on this half. We really keep going back to trying to build congruent triangles so that we can use CPCTC to get more congruent pieces. And if you remember back to first semester, every one of those triangle congruency conjectures required 3 pieces of information. I have 2. I have 2 pieces of information now. I have um, I have a congruent angle and I have a congruent side. I need something else. Well, they're going to tell me right here that I have a congruent side, and it is AE. And this is our famous reason that we used like a million times for a semester, the reflexive property of congruence, right? Segments are congruent to themselves. So now I've got the information I need. Don't worry though. You know, if you look at this, you're like, oh no, Mr. Jansak, ASS doesn't prove congruency, and you're absolutely right, it doesn't. But the triangle isn't really ordered that way. If we go up to the triangle and really check it out, what we end up with is um, the 2 sides, right? And the angle between the 2 sides. So it's really SAS, triangle congruent postulate. Okay. It was postulate 19, no, 20, postulate 20, if I recall. All right. Now we have congruent triangles, and that's huge because now I can use CPCTC to get other congruent pieces. There's 3 other congruent pieces I can choose from. I can choose, you know, this angle down here is congruent to this angle over here. That's 1. I could choose this angle up here is congruent to this angle here. That's 2. Or I could do the sides we haven't used yet. Those are the 3 remaining pieces that I could choose to say have a congruent relationship because of CPCTC. Which one is important to us? Probably the sides. I would say that AD and AB are congruent segments because of CPCTC. Okay, they spelled it out. We don't need to do that. We can just call it C. Whoa, that was bizarre. We could just call it C, P, C, T, C. All right. So how does that help us? How does knowing that these 2 chords are congruent help us prove that these 2 arcs are congruent? If you're thinking to yourself, Theorem 10.3, you are all over it. And that is the theorem that tells us that it's an if and only if theorem. So it tells us if you have congruent chords, they create congruent arcs. And if you have congruent arcs, they create congruent chords. So sadly, this, you know, you would have to prove that like 2 different ways to get the full proof. But go ahead and shoot me a message in the morning if you have any last questions before your quiz. But like I said, nobody asked any questions at all. So I'm hoping you guys are understanding everything. Mrs. Moore told me she had a Google Meet session today, Hangouts, and she has 2 classes, but like 38 people came. I don't think I've had 38 people total come to any session. So either you guys are really understanding it well, or you guys don't like my tutoring sessions, and that would make me very sad. You know what else would make me really sad is that if you're not liking circles, because I know that all these circle theorems and circle definitions may be bumming you out, but what I think is really important for you to understand is that circles are really on your side, okay? Circles want you to do well. In fact, here's a circle right here who wants you to do awesome tomorrow, okay? Look at that. I mean, that dude's totally rooting you on. He wants you to go and rock that quiz. So go and rock that quiz. It'll probably be similar to last week. It'll be released sometime in the late morning, probably close to noon, maybe a little bit before, and then I'll put a cap on it of around 3 in the afternoon or so, so that you have a nice, at least minimum 3-hour window to find time to take, a fairly short quiz, probably about a 30-minute quiz at most. Do well, and hope you're doing all right. I do miss seeing everybody.